So I thought we could have a quick review of some of the middleware and application interfaces that we have support on top of the DAOS API. Some of this is repetitive from last year's DUG, but we have a lot of our community has grown, and so it's probably a good idea to review some of those again. So you can see here on the slide, we mentioned this before. DAOS has a client library with a very rich API that lets you do a lot of things. However, our intention is always not to have all application developers go change their code to write over the DAOS API, and we want to support different middleware, existing middleware and very common middleware libraries to work on top of the DAOS API, so that provides a very smooth path for users to run on top of the DAOS stack. And so, in most cases today, everything is built on top of POSIX, right? Most of, libraries and all that can be run on top of POSIX if we just have support for POSIX API directly. But of course, also that's not our intention here because of, many limitations of that POSIX gives and, some limited functionality. And so basically the idea is to look at individual middlewares and write backends to them to be able to have, first of all, a better mapping from the middleware's data model to the DAOS model. And of course, to try to expose new functionality and others through the middleware API for applications to use. And so we will. You've heard a lot of talks, before mine on different middlewares that are not on this slide, like the root format, the segy, and all those. Today, I'm going to talk just about a few ones that are on this graph, basically the POSIX, the HDF5, and the MPI-IO, and we'll talk about some future also middleware that we are working on. So first, let's talk about the POSIX, our POSIX support and how we plan to support POSIX to users. We have the libDAOS API, which is, we've been talking about an object API that is very, very, very rich, but also sometimes not easy for users to use. And on top of that, we built what we call the DFS API or libDFS, which provides a POSIX-like API to users. It gives you the concept of a namespace, directories, files, symbolic links, and whatnot that you could program your application to use, which it's much simpler API, that more API that maybe users are familiar with. However, it still requires application changes since it's a new API, right? If an application that's using open read write needs to change their code to do DFS open, DFS read, DFS write. Although the interface is very similar, but it still requires somebody to go in and change their code. And this is, if you really need a namespace, this is basically the best path to performance is to use the libDFS API. However, and this is all again in user space. There's no system calls, no involvement of the kernel on any side, on any space. It's all still in user space at the DFS level. The second, on top of that, we have a Fuse plugin that for applications that really have no flexibility to change any of their APIs, any of their I/O, and we support that through Fuse. However, Fuse, since it's built into the kernel, it has very limited performance. It's not just specific to G-Fuse, and most Fuse plugins, they are limited. Fuse is known to have a severe performance overhead in this case. We're working on to improving the Fuse performance. We know it is severely limited today, but we are doing some changes to improve the performance a little. It's not going to match the DFS API, but performance. But we believe we can make it better than what it is today. And we have some options like today to enable caching in Diffuse. If you are running, on a single node, you can just enable diffuse caching to get better metadata performance, map shared support, and does some read ahead optimizations and whatnot. And this gives good performance if you are running on a single client node and you want a POSIX namespace or the POSIX API that you just want to test things on. Another approach that we have is using the interception library, and an interception library which basically again requires no application changes, but just a runtime LD preload to the interception library, and that intercepts the IO calls, read and write, and it would give you similar performance as if you are using the DFS API for read and write calls. Metadata calls will still go through Fuse and still impose that overhead. So in terms of consistency and POSIX semantics and whatnot, at the DFS level, we provide two flavors, if you want to call them, for different levels of consistency that users can select when they are mounting their DFS container. The first one is a relaxed mode that we call for well-behaved applications that prioritize performance over concurrency control and things like that. It's mostly for applications that know they are not doing a lot of conflicting metadata operations. In that mode, we handle simple things like everybody trying to create the same file, but we don't for more complicated things. Trying to doing really conflicting stuff like maybe rename or somebody trying. There are a lot of POSIX corner cases that we just avoid handling here. The other mode is more balanced, and in that mode we use internally we use a distributed transactions for all metadata operations that touch basically multiple objects or multiple redundancy groups, as we call them, and this will enforce a stricter level of consistency at the DFS API level. However, it does impose a performance overhead. For right now, actually, I lied on the slide. Right now, the relaxed mode is the default mode, but we will change that once we have the balanced mode fully developed to be the default mode. The idea is to do some benchmarking. Heavy benchmarking of both modes at several points in time, using benchmarks like NV-test and other metadata benchmark, and see the performance gap. And if we at some point we see we've bridged the performance gap and the overhead is very little, we can switch to having only one mode in that case. But I think today we still need the two modes for having the performance to addressing the performance overhead of the balanced mode. Following up from DFS, we have, as mentioned in a previous presentation before, we have an MPI-IO driver for MPIT that's built in MPIT today. It's added as an ADIO driver in ROM.IO. This implementation is portable to other MPI implementations, but we haven't done that yet. For most MPI implementation, use the ROM.IO driver and MPIT. But it's not always refreshed. So at some point we can work on refreshing the ROM.IO driver or work with the developers of the individual MPI implementations to refresh their driver with DAOS support. But in MPIT today, it's available in the upstream repo, and I think the 4.x or something release will have DAOS support there. And MPI-IO files are POSIX files or DFS files. It's the MPI-IO driver uses DFS underneath, so you can create a file with MPI-IO, access it with POSIX API or through Diffuse. It's all the same format and underneath. And the way that the MPI-IO driver works is that applications don't change code; they just change the path that they are accessing by appending DAOS colon to select the ADIO driver. And in terms of HDF5, there are HDF5 has, for a long time, HDF5 was built, what we call the native wall or the native implementation, let's call it. And then underneath it has something called the VFD layer, which has several backends, one of them being MPI-IO. So technically, yes, you can just use whatever you have today with HDF5 and that use the MPI-IO or POSIX driver, and that you can do that on top of DAOS. But the idea here is to have something more advanced and more in line with the HDF5 data model. And what we are doing is developing a new virtual object layer, which is also a new feature in HDF5 1.12 release that allows you to have a better mapping with the HDF5 data model instead of bytes and byte stream at the VFD layer. You have a concept of objects like HDF5 groups, HDF5 datasets, and chunking and things like that you can handle in the vol layer. So you have a better mapping of the data model to the DAOS model. And basically, this also allows you to add new features that we'll talk about in the next slide. So the idea is to develop a vol connector that we call DAOS on top of the for the HDF5 API. And using that vol there are several ways that you can enact. You use the vol instead of the native vol, and can be done through environment variables. And there is the unified namespace component that I will touch on later on the next slide. And this. What we have here, the components that are here are, the HDF5 library, the HDF5 API, the DAOS vol library, and, there are different test suites tools on top of HDF5 and other middleware. The status of this is that since last time we've talked about this, there was a specific version of HDF5 that you have to use, but now since 1.12 is released and the develop branch has been included to have the latest vol updates, so you can work with the latest develop branch of HDF5 or the 1.12 release that has vol support. So what we have also, since with the DAOS vol, there is a new API that is added to the HDF5 1.12 release that is not supported with the native interface, but only with the vol interface. And we call that the map API. And it basically, it gives users a KV interface to HDF5 versus just a data set, a multi-dimensional data set. It allows you to do something like in a KV object. Externally for HDF5 users that they want to use. That you can also use any of the HDF5 tools like H5dump, H5ls, H5 repack. I touched on H5 repack before in this slide here. Basically, if you've written a file using the DAOS vol, you can use H5 repack to convert it to a POSIX file system if you want for backward compatibility. If you have files that are already in the POSIX format and you want to change them to the DAOS format and vice versa. And soon we will have more features, and soon, maybe later this year, and in a later release of HDF5 and HDF5 vol will have support for independent metadata rights. And with the HDF5 vol, maybe that gives you things like independent object creation. And currently in the native API or the native HDF5 library, everything has to be done collectively. Basically, when you are updating the metadata, if you are creating an object, at all ranks in your MPI application have to call that create operation. But with the vol, we'll have an option to have independent object creation to the HDF5 API. We'll support asynchronous metadata and raw data operations, which is also going to be a new feature added to the HDF5 1.12.1 API. And we'll have some evaluation with real applications and other HDF5 middleware like that build on top of HDF5, like NetCDF4. So we are doing some evaluation there, and we can have some results that can be published soon on that front. And this is all on GitHub, the HDF5 and GF group GitHub, and you can grab it there. And there's a user guide for more information on that side. I touched on this before, the unified namespace. Basically, and we've seen in previous presentations that the unified namespace has, users have been working with UUIDs, for pools and containers, and there's like objects and all the addressing scheme from basically the DAOS API. So you can see in some presentation before, users have to manually specify, a UUID, DAOS prefix, and all that stuff. But we have features today that lets you have a more friendly approach to instead of passing a full UUID. And basically, when you create a container, you can specify a path in your file system that corresponds to that container. And what that path has, it has extended attributes that adds the UUID of the pool and the container. And so when a user provides that path instead of and uses the UNS library, they can the UNS library can programmatically take out of query that special file in your file system, and it returns to the application the UUID or the middleware, the UUID of the pool and the container. And so for users, it will be better programmatically instead of just passing a path as they are used to. What we are doing here is basically we have support with that diffuse, allowing you to do this in diffuse, being your unified namespace, but we also have more support with Lustre, for example. We are working with Lustre developers to integrate this, to have this extended attributes be better performant in the Lustre implementation, and it's basically stored as LOVA or LOVM. I forgot the name that's called for that, and it's basically a faster way to retrieve extended attributes versus a traditional file system where you have to basically have an extra round trip for an extended attribute. So there is a special integration with Lustre for this, but it's also going to be able to do. You can also be able to do this on other file systems that support extended attributes. And finally, some forward-looking stuff here. We are working on a MariaDB engine for DAOS. This is still in development and very early stage. But what this allows you, what MariaDB or MySQL server, it enables backend engines to be written as plugins. You have the InnoDB, which is the default engine. Technically, we can write a DFS API for InnoDB, and we have full, MySQL server support. However, we want to look more into a higher level. Again, same way we did with HDF5. Also look here on the MariaDB side to have a native engine for DAOS. And the main goal here is to leverage what we call in-storage computing. And basically, the MySQL server lets you, the engine interface lets you push something called a conditional pushdown optimization. So your query, you send your query to the server side to avoid iterating over all rows to construct the result of the query. So basically, it minimizes the network overhead and all the transferring all the rows from the server side to the client side and doing the query there, and just do the query on the server side. So yeah, this is still in development, and once we have something tangible, you'll probably hear about it. And that's all. And so maybe I took a little longer than expected. But
thanks a lot, Mohamad. No, that's fine. I think there was just a few questions on the chat. Maybe I will just read them. Yeah. You can answer directly. So, in question from Glenn, how easy is it to switch between consistency mode? Is it something that you select when opening a container?
Yes. So we plan to have different ways. You can use today. You can do it through an environment variable, but we plan to provide it just with an API when you mount your container with DFS.
Okay, and there was a question from Steven. When using MPI-IO, creating a file with a path like DAOS/path/to-my-file, one ends up with a container that has only the my file under its root, not the full path. Is it intentional or a limitation?
So I need to look more on the details of that question, but if Well, recently, we've updated the UNS library support in the MPI-IO driver. So as long as that path is in Fuse, you will see that file. But if today it's correct that in a previous implementation it was required to be able to. It usually creates the file just at the tip of the container, at the root of the container, so it ignores the path. But we should follow up technically on a more use case here.
Sounds good. Yeah, let's take it to the chat. Thanks a lot, Mohamad.